that way if tonight if you decide you're going to study or do whatever, you can just go to the YouTube site and you can look up any problem that you're not sure about. This is a very, very, very good review for the test, and I know that because I wrote both of them. So if you're rock solid on this review, then you should be good for the test tomorrow. Okay? So let's just get through this, and then we'll get back to the games at hand. It says, using the figure below, neatly draw the resulting figure after you reflect it across the y-axis and translate it using the rule x minus 3, y plus 2. First we're going to reflect it across the y-axis, right? Remember that when you reflect something across an axis, it needs to be equidistant from the axis. So in other words, the way that I do it, once I identify the y-axis, if this is 1, 2, 3 away, I go 1, 2, 3, and I put that vertex there. And then I begin working my way backwards. Let's see, so 1, 2, 3, 1, 2, 3. So this is the resulting figure when I reflect it across the y-axis. And then I'm going to translate it using the rule y minus 3, which is basically left 3, up 2. So I go 1, 2, 3, 1, 2, and then I can put the figure just, let's see, 1, 2, 3, 1, 2, here and here, making the resulting shape right there. Alex, question?
But since it says after you reflect it and translate it, you wouldn't draw the reflected figure, right? You just stated that.
No, but I'm explaining how to get to where we're going. Okay? I'm explaining how to get to where we're going. So this is the correct resulting figure. Okay? By the way, one thing that I noticed on the homework I've actually noticed on a couple of homeworks now, some of you, when you're moving a figure that has named vertices, you're not labeling those. Label them. Okay? If it says triangle ABC, I expect to see the vertex A, vertex B, vertex C, and then whenever you transform it wherever it's going, it becomes A prime, B prime, C prime, and if you do it again, it's A double prime, B double prime, C double prime. Absolutely. Nope. That is a geometry rule. Okay? Andrew, do you have a question? Okay, so on this one it says, Sally's building a raised garden as shown below. She needs to fill it 2/3 full of dirt for her plants. How many cubic centimeters? Well, whether it's 2/3 full or we're using cubic centimeters, what do we know we're finding? We're finding volume because we're filling something. Remember, volume is about filling something. This is V equal area of the base times the distance between the bases. Yeah. Now, you kind of have to pick a base, if you will, so that when you find the area of the base, you can do that. I picked the bottom, that bottom down there, which meant that basically I do 180 times 90. 180 times 90, and then times 30. So basically we end up with 180 times 90. This is area of the base times 30, which is the height. And when you get that, you end up with 486,000. Times 2/3. Now you can do that one of two ways. You can do times parentheses 2 divided by 3 in your calculator, or you can do times 2 divided by 3. Okay, either one works. Alex, but your answer should be 324,000 cubic centimeters. I don't want you, if you got the right answer, I'm perfectly good with that, but I don't want every single time you giving me a different alternative way. Got it? Just stay with me. Because what you probably did is you just took 2/3 of 30 and made it 20. I'm glad. Again, I get it. Thank you. Okay. All right. Any questions on that? All right. Number 3. A rectangular prism has a volume. A rectangular prism has a volume of 562.5 cubic meters. It has a length of 5 meters and a width of 15. What is the height of the rectangular prism? Now, if we go with volume, we know that volume equals area of the base times the height. But we can break that down one step further and say that the volume equals basically length times width times height, right? That's unique to a prism. Then we simply fill in everything that we have. It says the volume is 562.5, so we put that where the V is. It says that the length is 5, the width is 15, and we do not know the height.
You have to draw figures still, right?
No, it didn't say to draw it.
Every
Yeah, but we should be to. It might be helpful, and I'm good with that. But I'm not grading your review. I'm just going over it. Okay, so that you understand how to get there. Which means 562.5 equals 75H. You divide both sides by 75. Oh, why did I do that?
You said 0.5, you just wrote.
Yeah, that happens. 562.5, which gives you a height of 7.5.
You forgot to put meters cubed.
It's not meters cubed.
I can put meters cubed, I promise.
Okay.
I just.
Okay. It's funny though when you correct someone and you're wrong. That's the funniest thing when that happens. Okay. 7.5 meters. Okay. No, not meters cubed. We established that. Okay. The triangle has vertices at -4, 6, -4, 4, and 0, 4. What are the vertices after a reflection across the x-axis? Now, this is one of those things where you can either choose to reflect it or you can use the rules. What is the rule for a reflection across the x-axis? Does anyone know, Labib? You change the y to its inverse. So A prime actually becomes -4, -6, B becomes -4, -4, and C becomes 0, -4. Now, if you had, bless you, gone ahead and reflected it, you would still see that. More importantly, on your test tomorrow, you will have a coordinate grid. If you're not rock solid on the rule, then do the reflection yourself just to make sure. You don't want to give away points because you misapply a rule for whatever reason. What are the vertices after a dilation of triangle ABC using a scale factor of 1/4? Again, we go back to the original and we multiply each thing times 1/4. So this goes to -1. This is 1.5. B prime is -1, 1, and C prime would be 0, 1.
Would it be -1.5?
No. You multiply 6 times the scale factor. You just multiply each term, the x and the y term, by the scale factor. And then it finally says, what are the vertices after a 90-degree counterclockwise rotation of triangle ABC? Now, who can tell me what the rule is for a 90-degree counterclockwise rotation? Brendan? Shh, Brendan.
Switch and change the y.
Switch and change the first or the second?
The second.
Wrong. Switch and change the first guy.
Yeah.
Okay, that's what I'm saying. Some people, yeah, but what I'm,
Because the second moves. It's y.
well, that means the second is the first. Ah, so what my point is another way to think about it if the XY thing doesn't work is for a 90-degree counterclockwise, you're switching the X and Y, and then the first one becomes its inverse. For a 270, you switch them, and the second one becomes its inverse, okay? So what you end up with is 6, -4, which then becomes -6, -4, okay? B prime, you switch them, so it's 4, -4, so it becomes -4, -4, and C becomes 4, 0, which becomes -4, 0, okay? Any questions on those guys? Remember your rotation rules, please, 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 please. Alrighty, rolling right along. Number 5. After a translation, vertex A is located at -7, -1. Now, here's one thing that was key on one of y'all's worksheets. I noticed that I got a couple of y'all. Like there was the one we did the multiple ones, I think, and it said after a translation, and some of y'all assumed it was a dilation. Okay? When I say after a whatever, I'm telling you what the move is. Okay? So, and we know a translation is a what? A translation is a slide or a move. So basically what you have to figure out is where vertex A started which it started at 1, 2, 3, 4, 1, 2, 3, 4, 5. So it started at -4, +5. That's where A was. To get to -7, what did the x value have to do? Very good. X minus 3. And Nolan, what did the y value have to do? Subtract 6. So this is the translation rule. Once we establish the rule, we simply go to vertex B, which is at -2, 1, 2, 3, 4, 5, 6, 7, 8, which is at -2, 8, and then we simply apply the rule. That would put it at -5, 2. -5, 2. B prime is located at -5, 2. Labib? Mhm. Yeah, there are a lot of ways to do it. I'm just giving y'all one example. Y'all could actually physically move everything if you want to. But make sure that you got -5, 2 as the location of B prime. This is a composite figure, two different figures, and it wants to find the volume. The first one is a what? What is this? It's a triangular prism. So we know that the volume equals area of the base times the height. So in this case, the area of the base is 1/2 11 times 8. 1/2 times 11 times 8, which is 44. And we know that the distance between the bases is 17. So the volume of the first one, of the triangular prism, is 44 times 17. The next figure, here and here, is a rectangular prism. So volume equal area of the base times the height. Area of the base, the way that I drew it, is 8 times 5. And the height, or the distance between the bases, is 17. So the volume equals 40 times 17. So once you do all your math and you add everything up, you should get a volume, if my math was correct, of 1,428 cubic inches. Okay, check your, hey, and by the way, this is why you show every step. You should be able to cross-reference your paper against every step I wrote. And if you are just writing the answers, ladies and gentlemen, on the test tomorrow, I will absolutely count it wrong, even if it's a multiple choice question that you get right. I will count it wrong without supporting mathematics. And I said it in a recording, so when your parents go, why did he get it wrong if he got it right? I said, because he did not show work. I want the steps shown. Christopher?
Wouldn't it be easier to add the area of the triangle and the rectangle together and then multiply by 7?
You could have done that. It would have been different. I don't know that it would have been easier. The computation is, especially with the calculator, the computation is basically the same. But what Christopher is saying is, if you had taken this area and added it to this area, that would be the area of the base of the entire figure. And then you just multiply it times the distance between the bases. So you would still be doing area of the base times the distance between the bases. And that's perfectly valid. It's perfectly valid. Okay? You're going to see as y'all move up, there are a lot of different ways to deal with these things. Okay? Just make sure your way is mathematically sound. Let's blow through this. 7. A cylindrical water glass has a diameter of 8 centimeters and a volume of 401.92 cubic centimeters. What is the height of the glass? We know that for a cylinder, for volume, the volume is area of the base times the height, which is pi r squared h. And we know that the radius is 4 centimeters. So then we start plugging everything in. We're going to use this formula and plug in what we have. Well, we know the volume is 401.92 equals pi, which is 3.14, times the radius squared times the height. So when you do this math right here, you end up with 401.92 equals 50.24h. Oh, I said 24h and no h. I'm having one of those days. 2h, 2h squared. And now what do we do to isolate the h? Divide both sides by 50.24 and you get a height of 8 centimeters. Cam, do you have a question? Okay. Number 8, Ken is hired to build a straight road that connects the highway to an airport. The road will be 5 meters wide, 0.25 meters thick, and 3 kilometers long. How many cubic meters of pavement will he need to build a road? Now, once it says how many cubic meters, what do we know we're finding? We are finding volume. But what do we have to be very, very cautious about? Diana? The measurement. We got a unit of measure that was wrong. So we need to convert this to meters. Right. 2, 3. Yep. So what we end up with is a pretty simple area of the base times the height, which again, and when I use rectangular prisms, I still go 4th grade and just do length times width times height. You know? And once you get that, you end up with 5 times 0.25 times 3,000, which gives you 3,750 cubic meters. Yes, sir. It's how I do metric conversions. I'll explain that one day. Okay, let's get through this. What is the volume of a sphere in terms of pi? And once we see this, we should be thinking happy thoughts, right? The diameter of the sphere is 18 inches. So we end up with the formula, which is 4/3 pi r cubed, but we don't have to use 3.14. So what we end up with is 4/3 pi times 9 to the 3rd power, because that is the diameter. Once we do all that, we end up with 3,052.08 cubic inches. Pi. Oh, very good. Pi. Oh my gosh. So here's, oh, I'm totally wrong on this one. I set it up with pi, and then I actually multiplied everything. So what's wait, I can do it. 243 times 4 is 12, 16, 17, 972. 972 pi inches cubed. I set it up to be easy, and then I made it harder. That was stupid. Lots of mistakes. See? I know, it's terrible. A grain silo, right, Leilani? A silo holds 2,355 cubic meters of grain. If the silo is 30 meters tall, what is the radius? So we end up with volume equal pi r squared times h, pi r squared times h. And again, you'll notice that we're doing a lot where we're working backwards. That happens a lot on this test. So we end up with 2,355 equals 3.14 times the radius squared times 30. Okay. Okay. Now, does everyone understand what I've done? I was given the height. I already had pi, and I was given the volume. I was not given this, so I leave it as r squared. Now, what I can do is I multiply the 3.14 times the 30. And what you end up with is 2,355 equals 94.2 times r squared. If I divide both sides by 94.2, I end up with r squared equals 25, which means my radius is 5 meters. Guys, when you have a variable to a power, leave it and get it by itself, and you'll end up with something that becomes a little bit more solvable. Okay? Number 11, if you are comparing a cone and a cylinder whose radii and heights are the same, what would be the simplified ratio of the volume of the cylinder to the volume of the cone? What that means is we're going to find the volume of the cylinder over the volume of the cone. Now what I did is I simply used the formula. What's the formula for the volume of a cylinder? And the formula for the volume of a cone? Now I want you to watch this. Mathematically, if we've already decided, Andrew, you need to be watching this, put it away. Don't even leave it on the desk, just put it away. If you have variables over themselves that are identical, they actually cancel because the measurements are the same, which means that you're left with 1 over 1/3. And 1 divided by 1/3 is 3, or 3 over 1. Because it specifically said cylinder over cone. Jackson? Volume of a cylinder is B times H. Volume. If you just, before you ask, read. But Mr. Jackson. It's asking you for the ratio. It's asking you for the ratio. It's a comparison of two things in a particular order. If you think about it, if you take someone who's half another person's size, you can either say, depending on which direction you're going, you can say the other one is twice his size or this one is half his size. They're not the same. One's half, one's times 2. So you have to pay attention to the order they're asking you for. They're asking you to compare the cylinder to the cone. The cylinder to the cone is a ratio of 3 or 3 to 1 because it's 3 times as big, which means that this is 1/3. Because this is the ratio of the volume of the cone to the cylinder, so you end up with 1/3 over 1, and 1/3 divided by 1 is 1/3. Just leave it. Just leave it. Just leave it, Labib. Okay? Just a couple more and we'll get going. Find the volume. In order to find the volume of this particular object, what do we need? Area of the base times the distance between the bases. And these are the bases. Now to find the area of that particular object, we need to know this, and we need to know this. Base times height divided by 2, that's a triangle, equals base times height divided by 2. Problem is we don't know this, but what we do know is that if you draw it like this, you end up with 13 and 5, which makes this the thing you're looking for. And when you use Pythagorean's theorem, you find out that x is 12. Now what that means is that the area of the base is 10 times 12 divided by 2. You made it a right triangle by drawing something that's perpendicular to the base. Yes?
Why would you have to do that just two triangles?
I don't know what your question is asking, to be honest. No. I don't understand what. Shh. I'm finding the area of the triangle. I have to find the area of the triangle because that's. Shh, stop. Because that's what this is. Area of the base. So I end up with 10 times 120. 10 times 12, which is 120, divided by 2. The area of the base is 60 square meters. And the distance between the bases is 18 meters. So you end up doing 60 times 18, which is 1,080 cubic meters because it's volume. Make certain you know how to do that. Okay? All right, last two. If a rectangle is dilated by a scale factor of 3 and you compare the image to the pre-image, what can you tell me about the side lengths of the two shapes? Who's got an option on this one? Brenda, go ahead.
The new image will have 3 times longer sides.
That's exactly right. The image, the side lengths of the image will be 3 times longer than the corresponding sides of the pre-image. Now listen very carefully when we talk about this. Corresponding sides is an important thing to understand. When you apply a scale factor, don't just say the sides become 3 times as big, because that's not specific enough. The corresponding sides become 3 times as big. By corresponding, it means basically the same sides of each object. So the corresponding sides become 3 times as big. What happens to the angles of the two shapes?
They do not change.
So how do we say they do not change mathematically? They are congruent. The corresponding angles are congruent. The corresponding angles are congruent. The corresponding sides change.
Wait, but it's a rectangle.
I know, I'm just giving you, it's easier to give you an example using this. Okay? And the areas, what happened to the areas of the two shapes? Hatai? The area of the image, is it? It's not if it's a scale factor of 3.
No, it's not. She says the 3
Oh, I thought you said the image is 1/9. You said the pre-image. Okay. So here's what happens. So if you have a triangle that's 2 and 3, and you apply a scale factor of 3, you end up with 6 and 9, right? Rectangle, I'm sorry. So the area here is 6. The area here is 54. So you have to ask yourself, how do you get from 6 to 54? Alex?
This one's easy.
Okay, but it's not. That's not what I'm looking for. What you're essentially doing, because you're really multiplying it times 3 twice, you multiply the area times the scale factor squared. You multiply the area times the scale factor squared. And it makes sense if you think about it, because you're multiplying it times the scale factor twice. One time there and the second time there. But I don't want you thinking, oh, it's just times 9. It's not times 9. It's times 3 squared, because 3 is the scale factor. Makes that's exactly right. If the scale factor was 4, it would have been times 16. The scale factor was 6, it would have been times 36. Yes? Okay, last one. Here we go. What volume of cake batter will fit in the cake pan shown below? The height of the pan is 3 inches. So what we basically have to do, oh my goodness, interrupting is killing me. We find the volume of the entire cake pan, and then we are going to subtract the volume inside. So what we end up with is volume equals pi r squared h of the large one, and on the large one I get 523.125. When I did the volume of the, and this is the larger size.
Wait. You wouldn't round from the beginning?
No.
You only round your final product. Well, no, you don't even need a round. Because he said don't round. He never said anything to round.
Brendan, a review is supposed to be where you learn something, so don't freak out. Calm.
And this isn't even great.
The volume of the inner ends up being 20.925. That's the volume of this. When you subtract, you get 502.2 cubic inches.
Wait, I still got the right answer.
Then look at you complaining for no reason. Okay, hold.
That'd be 1.5, right?
This would be 7 point,
I thought you got the middle part would be
1.5 is the radius. Shh, hey, everybody, hold.
1.5 squared.
Just a second. Cameron, sit down. Labib. Cameron, give him his tennis ball. Everyone just hold tight for a second, please. Jackson, what's your question? On the volume,
1.5 squared would be 2.25.
3.1 times 1.5 squared times 3.
Yes.
That is 20.925.
I got that. Wait.
And then this one is 3.1 times 7.5 squared times 3. Check it with the calculator before you freeze. Okay, I'll come get with you in just a second. Everyone else, all this will be online, including the answer keys. You can check it. Make sure you're ready for your test tomorrow.